Now you are?
I'm Martin Schaefer.
Okay. And you have a cosmic ray exhibit here? Or?
Right. This is a cosmic ray muon detector.
Okay.
And we use it to study the flux rate of cosmic rays.
All right. And what importance is that of, what do you get out of it?
Well, this is the primary source for our carbon-14 isotope. If you've heard of the carbon-14 radiometric dating, the source of that carbon-14 that comes from these cosmic rays hitting our upper atmosphere, colliding with particles, in this case a nitrogen atom, and changing it from a nitrogen atom to a carbon-14.
Okay.
And this is a cycle that continues, and this is why we have a constant supply of the carbon-14 isotope that we can use for carbon dating.
Yes. Okay.
That's one of the purposes for that. Another thing is starting to affect our electronics. As our electronics are getting smaller and smaller, these charged particles that are flying through at the speed of light are starting to affect the electronics a little more. Some theorists have suggested even the Toyota problem could be from these cosmic ray muons.
Wow.
I believe I read something that the IBM is now starting to investigate putting the cosmic ray detector inside the circuit boards in their computer, because these cosmic ray muons will actually cause it to lose data. So like 250 megabytes, 250 megabytes or something like that, and you lose data, causes file corruption in your computers, and so it's starting to affect our electronics as we get smaller and smaller in the way we design them.
All right.
And so I think it's going to be important in the future to understand what's actually happening with these cosmic rays. We're also using these to understand neutrinos as well. One of the big movements in United States science is neutrino research, with NINOS and the NOVA project coming in the Chicago area, Chicago, Minnesota area. And for each cosmic ray muon that I'm detecting here, there's going to be 3 neutrinos that are being produced.
Okay.
And so we can actually use cosmic rays to determine things about the neutrinos. And so there's a lot of different things that we can actually do with this. What I do is I teach this and I use this in my physics class in high school, and my students do actual research with cosmic rays, understanding not only accuracy and precision of a detector, but we actually measure the speed of the detectors by separating these detectors. We separate them by 2 meters apart, get the time in which a muon hits up here, the time in which it hits down there, and we can actually measure the speed of these muons as we go through.
Okay.
Studying things like kinematics.
Yeah.
We can look at the angle in which these particles are coming in, when they're studying vectors. And so I'm able to integrate this into a lot of our classical mechanics lessons in the physics class.
Okay, well, that's pretty cool. Okay, well.